So intersections, unions, and counting. And we'll use that example I had a moment ago where we were looking at whole numbers less than 10. We have a set of odd numbers and a set of prime numbers. And so in the middle here, they have in common 3, 5, and 7. And then otherwise, we had 1 and 9 as prime and 2 as another odd. And we were calling these set A for the odd numbers and B for the prime numbers. And then we had all the numbers that were living outside there. So out here, we had 0, 4, 6, and 8. And just some things to keep in mind. The number of elements in set A, that's called its cardinality. There's 5 elements in set A. Number of elements in set B, in this case, there are 4 elements in set B. If we look at the intersection of A and B, we can see in the picture there are 3 of them. And when I look at the union, A union B, I have 1, 2, 3, 4, 5, 6. And so it turns out there is a relationship between these numbers here. The number of elements in the union, A union B, is related to the number of elements in A and the number of elements in B. So a union is kind of like an addition, but with a union, we don't double count, right? So far I could say, well, yeah, A has 5 elements in it and B has 4 elements in it, but this 5 counts those 3 numbers in the middle and this 4 counts those 3 numbers in the middle. So I have to take away the fact that they have something in common, and what they have in common is their intersection. In the intersection, I just remove that double count of 3. So we counted the 3 here and here, we remove it once and we should be good. 5 plus 4 is 9, 9 minus 3 is 6, which is clearly what I see in there. So this is an important formula to know about the relationship between unions and intersections. That it's when we count elements, it's very much like addition for a union, unless the sets have something in common. Then we got to take into consideration we accidentally double counted here, so we take that intersection away once, and then that sets the books right, and we get the right total for the union, which is displayed in the Venn diagram also. So unions, intersections, and counting. All right, so those are all the big ideas in section 2.1. Now we just got to play around with using them in different ways.